So here we are in our Thursday section for week 2 on categorical data analysis. And our major issue, of course, this week is for our Thursday section, I think the goal is to basically review the homework assignment that we had before. That being said, I'm more than happy to review some of the other questions we might have with regard to, data analysis, navigating the course website, all of those kinds of little things that, maybe are an issue. So that being said, there's our opening sort of summary. There's the dates. I think as we begin, are there any other questions you might have regarding some of these issues? Other than maybe review of the concepts, are there questions about navigating the course website, the flow of the course, understanding sort of the data analysis part of the homework assignments, submitting it, anything that might even fall into the realm of the technical? If so, feel free to submit a little chat box and let me know. Now, I don't think I'm seeing anything in the chat box, but I want to make sure that I'm not missing anything either. Oh, here we go. Thank you. So someone had asked, is the mission assignment the only homework? Thus far, so when we grade homeworks, the weekly homework assignments that are due at 5 p.m. Eastern Standard Time or Eastern Daylight Time, whichever way you want to call it, those are the homework assignments that are graded. The rest of the quizzes that you take up until the end of each module, which you should complete by the end of each module, you should complete your quizzes. Those are pass-fail. In other words, we view the quizzes as opportunities to learn, and you do that interactively. The homework assignments themselves are opportunities to get points and to basically improve get an assessment also on progress on the homework itself. So long story short, the homework assignments, yeah, complete them every week if you can. And if you don't have those, if you somehow have a bad week or you couldn't finish one, because I know a lot of you are very busy, you have multiple jobs, you have multiple obligations, then in those cases, we only ask that we will only assess you on all of the homework assignments that you've done so far, minus the one that you just decide to drop. There's another great question regarding the final. The final project groups will not be assigned. This is actually different than a group project. This is an individual project. Most of the students in this course are taking it for graduate credit. Not everyone, but that doesn't matter. But I'm going to weigh my emphasis toward the graduate level students here. The final project I see how do I put it? A wonderful opportunity for you to express yourself using data analysis. Now that might sound a little strange, but the point I really want to make, and I'm going to have a video posted to the tutorials page maybe around mid-semester, regarding how do you develop and write up a research project. And the main point I want to make is do something that is useful, that has data, do something that is really of interest to you, that has data, and that is somewhat statistical. Hopefully with using some of the techniques and the tools that we've used in class. The reason I emphasize that sort of more personalized approach, not only is the syllabus pro forma emphasizing this project as something that you do, but it is also a great opportunity for you to do something that maybe might reflect your own personal interests, It can work great for a portfolio. It might be good for a graduate thesis. It might serve you in some other purpose as well. And because of that more personalized nature of the final project, while we don't require it, I definitely invite you to come and talk with me or talk with the other TAs or the other teaching staff regarding the final project. That being said, don't worry about it too much. But if you have some ideas and you want to talk about it with me, especially if you're assigned to me as your TA, that's the person you need to talk with about the final project. If you're not assigned to me as a TA, I'm more than happy to talk with you. The only issue, the only caveat is that I'm not grading you for the final project. So that's the real sort of more formal distinction between TAs. Some TAs, the reason if you are assigned to me as your TA, I'm here for grading purposes. Otherwise, the resources that we provide, the reason we post all of the sections online is so that everyone has an opportunity to learn from every section and from everything else. We want to provide as many resources as possible. Okay, thank you. No worries for those of you who have to leave late. For those of you who arrive early or late, no worries. This is why we post this online. Okay, any other questions, maybe perhaps even regarding the nuts and bolts of the section or any other questions that you might have, especially given that this is the day in which we have the homework assignment due. And you can see that next week's material have already been posted on numerical data analysis. Nope. Okay, great. All right. We'll see how far this goes. I'm gonna show you the homework assignment with some obvious errors here. I'm gonna do a new share, and this will be the homework assignment right here. So here's what it looks like. You can see that I finished it in a minute right before class. Well, guess what? I kind of know the answers here anyway. In fact, you'll see I sort of threw this on question one. I purposely answered the wrong question. Typically, that's what you'll see if you have the wrong question answered. You'll have a little bit of a red message there. You'll see that it's a little red box. I should have answered an answer correctly, but I know these answers already. You might already get the feel, sort of the flow of a homework assignment. And the reason I want you to get the flow of a homework assignment, oh, thank you, yeah, okay, good. Someone's saying, we guys have some nice words here. This is the virtual version of an apple on the table. That's okay. I can eat kind words. Those last a lot longer than apples. I want to emphasize that this class is not about statistical programming. I know there are those of you who are really keen, and I'm very excited about those of you who are very savvy with the statistical software. And that's great news. For data science in particular, R seems to be there. That being said, R may become passé. There are other statistical languages out there. What will probably stay, and what will definitely stay, regardless of whether or not it's debated, are the statistical concepts. And the reason I want to review the statistical concepts is that these are the facets of the homework and the quizzes that will be tested in both the midterm and in the final exam. So this is sort of the other side of the data analysis procedure, which is essentially learning and interpreting statistical output, learning and interpreting statistical concepts, and applying those. We do have some numeric answers, but those are rudimentary. It's just some simple arithmetic. The only time you'll need to really get into data analysis is for the final project. But again, it's to your benefit to meet with me if I am assigned as your TA, or with Regan if she is assigned as your TA, or with the course instructor as well, to decide, well, what is of interest to you? But that being said, let's just learn the concepts. So shall we proceed? We have a good 40 minutes. I think that's more than enough time to cover this issue. So here we go. I'm going to talk to you about the flow of the homework assignment, because almost every other homework assignment is going to be the same. And essentially, you have one part that emphasizes key concepts, and that does not require you to download the data set. It does not require you to do any data analyses. What's the point here then? Well, we are inundated with statistical outputs. We're inundated with statistical reports. So while you will see something quite similar, you will see statistical output that is actually from R and using the Titanic data set, it is not required. And sorry about that, and I just had to close the window. It is not required for you to actually download and analyze R here in this case. Okay, so I'm just going to scroll pretty quickly. You typically have about 3 or 4 questions here. You might have one that is sort of a, I don't know, 1-point question where you have a couple answers. You might have more answers on the numeric responses. And these are kind of like a true or false type question. You'll hear question 4, you'll have a true and false. So basically you have numeric, multiple choice, you'll have sort of affirmative or rejection, multiple choice, and then you'll have true and false multiple choice. Then what you'll have often is you'll have a group of output here. And if I can even annotate this, I can be a little sloppy. See this output here? The implication here is when you see a group of outputs, the following questions after that are going to reference that analysis. I can't even move this. I'm going to clear my little annotation. And that's what we have here as well. You have these questions that are related to this output that we just presented. So if you're not exactly certain about which output is being referred to in the question, look at the most recent output that is presented in a separate box with the analysis that describes the data set in question. And for the homework assignments, we're focusing on the data set that you're going to analyze. And you can actually even cross-validate this. If you want to do your own analyses, you'll actually see that these are the numbers that you get when you do your own analysis. So you'll see some other questions here, and basically those are as simple as we can get. Sometimes there might be some ambiguity in interpretation. Now, how do I explain this? Well, in the sense that maybe, say, question 9, not in this case, but maybe there might be a question that draws upon earlier outputs. Say here we have questions 5 through 9, referencing this table of output relating social class and survival status. That being said, it might refer at some points to this data set here. You don't see this in this example. They're pretty much separated. But I just want to emphasize that point here. If it's the same data sets and you think that the question 9 or 10 might incorporate some additional information or might benefit from that, and that makes you more confident of the answer, then that's probably going to help you. So here I am sort of talking a little bit about the flow of the analysis or flow of the homework assignments, and it's going to be very, very similar for the rest of the 9, 10, whatever homework assignments that we have. But I'm also giving you a good idea of sort of the I say the goalposts, the benchmarks about where is the information that the question is referencing. And this is extremely important if you think about these first 10 points that you get for each homework assignment. Important for several reasons. Okay, we all want to do well in class. I know so many of your graduate students, you might have not liked this. It may have been many years since you've taken stats. Well, the main point, or even you don't like programming, you're uncomfortable with the data analysis part. Well, the point here is this does not require you to even do any data analysis. So already, just through interpretation, just through listening to the class material and going through the modules, you should be able to, with some native intelligence and guesswork, figure this out. I'm not saying should, but you probably are able to. That's what I should say. You'll see in terms of point assignments, some of these problems are 1 point. Sometimes they're 2 points if they're a little more difficult, or there might be some curveballs here. The reason is that some of the answers might seem patently obvious. Others of the multiple choice answers draw on a different kind of logic here that might be a little distracting. And I can tell you how to answer my strategy for answering multiple choice. But I want to go through the sort of the workflow of your homework assignments. Here we are on the second part. This is what I reviewed on Monday. And if you look at all of the R tutorials, we go through this in exhaustive detail. Here's the data set. Here's the code. Now, as long as you have R installed and you have Mosaic installed, then all you have to do is type in the library function, and you should be good to go. So on the website, you just, I think you can do this right now. I might be able to download it here from this. No, I can't. Whatever. I thought I could. Well, anyway. The point is, all you have to do is download the data set, put it in one folder on your desktop, download the code, put it in another folder, in the same folder in your desktop. Double-click the code file, which is a .r file. Open through the drop-down menus the data sets and run the code. You can just highlight all and run it. So here we are getting you used to the data analysis part by getting your feet wet. But I think for those of you who are starting out, this is also a good opportunity for you to do relatively little, to be honest. Because what you'll see in RStudio is the output, that it will look quite similar to bits and pieces of the output that we see here. If we look at this little section here, you see this output that I'm highlighting. That's essentially what we're going to do when we ask you the questions about the data analysis. We're just going to ask you questions that really draw upon either the plots or the output that you analyzed, with the hope that this code you can get more used to, you can understand it better with the R tutorials. You can actually do your own kinds of analyses that maybe aren't required, but that this is all for a tool for you to do the best kind of final project you can do. And I say that because I think of the final project as the pinnacle of this class. Because if you're applying for data science positions, I've spoken with recruiters. What do they tell me? Do they care about homework assignments? No. They say, this is what they've told me. People at Google, at, I don't know, Facebook, they say, do an interesting project. Do something that's fun. And that's the main thing. It's good for your portfolio. You can post this to online sites through GitHub, and you can do that using RStudio and R. So we're giving you not only the programming language essentials, but we're also giving you, I think, opportunities to get as much or little into the code so that you can do a final project for your purposes. Now, if you just want a good grade and you want to move on and you want to do something else, I think the class is tailored to that. So that's what these questions are when we look at the second part. That being said, even though I said it's relatively easy, you cannot answer the rest of these questions without having already installed our RStudio and Mosaic. And Mosaic is a library of a whole bunch of functions that use the code that we offer in class. It is not the only way to do it, but I think it has a relatively intuitive logic to it. If you look at the discussion board, there's some interesting comments about what this little squiggly line is used for in the commands. It's called a tilde. And I tried to explain how there's a certain logic that goes through those commands that aren't for everybody. And if you look at other people's code, it may look like Greek to you, but it's useful, I think, for learning these concepts and getting your feet wet. And that's how you do it. You don't learn statistics If you learn to swim, I think statistics is a lot like swimming or playing jazz, maybe. I'm a musician. But if you want to play jazz, yeah, it helps to read a book about jazz. But really, the best thing to do is play. In jazz music, they'll often refer to woodshedding. And this is the concept of going into a woodshed, isolating yourself, and just figuring it out, playing the scales, playing the chords, dissecting the song, the tunes you want to play. Well, data analysis is much in the same way. You have to go and just figure it out, get your feet wet, get involved. Same with swimming. Don't read a book about swimming, go swim. This is what we really want you to do for the course. Someone is asking about we'll talk about that. Someone is asking about your present working directory. It's more of a stats question, but I emphasize it pretty frequently. I'll see if I can post that to the R tutorials page. But I want to bracket that for now because I do want to focus on the concepts, but I will say something about that in this section. Someone else is asking about, is the R code given for each assignment? Yes, it is. So when you see part 2 on data analysis in R, it's the same flow. Notice I'm talking not about the questions, I'm talking about sort of the workflow, the arc of the homework assignment. This is because the first half will be questions that are multiple choice or true, false, that reference the data set or show output or show results, most likely using the data set. And the second part has similar questions that require you to download the data set and use the code provided. The data set and the code provided is all that is necessary for you to complete and run the analyses. We're not asking you to write new lines of code. We're not asking you to construct something de novo. We're asking you to simply get your feet wet. And if the water is too cold, that's okay. Put your tiptoes in and take a look at the code and just get a feel for it. And if you are a little bored with this because maybe you're a computer programmer and you're used to SQL or Python, or you want to know more about using the functions available or using base commands, R is your toy box there. I think the instructor, Ethan Fossey, had mentioned there are about 11,000 packages in R. The point is, imagine you go to a library with 10,000 different ways of doing things. So this is the strength of R. It's sometimes slow, it sometimes crashes. Maybe it's not as good as Python, which is increasingly popular. But it's free, and it's a lot like Wikipedia in that sense. And like Wikipedia, there's something for everyone. So no matter what your statistical problem is or what your statistical focus is, you can typically find the kind of analysis you're interested in. So that being said, we're just going to focus on the concepts here. So I hope that answers your question. Someone is asking about the final project, about our data and the code that we provide. The point for the final project is to do something that is of interest and of use to you. It is not, however, to replicate or reanalyze with the same findings the data and the code that we provide. In other words, it has to be original. So if you're using the Titanic data, for instance, give us a new interpretation of the Titanic data, right? It's sort of like going back to high school English, perhaps. If you're going to read Hemingway, you're going to read The Old Man and the Sea. It's a relatively short book. It's a good one. Good for the high school students everywhere, short on time, or college students even. What are you going to say about The Old Man in the Sea that is going to be a little bit different? Well, it's the same sort of thing here. Okay, what do you want to say about the Titanic data that's a little bit different? That's why I encourage you to maybe perhaps use bits and pieces of the code that we provide to do your analyses. But I would really encourage you to download and find data that are available. On the discussion board, it's actually pinned sticky to the top of it, are a plethora of websites where you can download data, and you can actually import those into R as well. So I would really recommend you to use your own data and apply the code that we use, like a histogram, or we haven't gotten to that, that's next week, sorry. Maybe say do a pie chart, I wouldn't say pie chart, a mosaic plot of 2 categorical variables using a new data set, right? You could say percentage reporting smoking cigarettes in a state and percent voting for Trump. I don't know, just something random like that. That's what I would do. So that being said, we don't have any hard and fast rules. The best bet against any kind of concerns, reach out to your TA. You can reach out to any of us, but I'd say reach out to your TA if it's in particular regarding issues concerning the project that you will be graded on. If it comes to some technical stuff with R, feel free to reach out to me. I've been posting a lot of the R stuff, and I have done an advanced R workshop before. So if you're feeling like, okay, you want to do something more and you want to do it now, I can direct you in those places. That being said, the more advanced the stuff is, it's not required for the course. This is an introductory course. Any other questions regarding the second part, regarding what we provide for you and what our expectations are for the data analysis part? Okay. Scroll down. Wow, I actually missed a lot of these questions. I'm sorry. Well, I got 0 out of 20. I'm not too worried because I'm going to drop the lowest of my problem sets or my homeworks. What you should be concerned about, I should say, is make sure you finish those quizzes. We're not grading you on those, but that is a huge portion of your class participation. And we can track those. We want to be sure that you are completing those homework assignments. And frankly, I could care less if you missed all of your homework assignments, but you got if you missed all of your quizzes, you got a lot of them wrong, but you did them diligently, but you did excellent on your homework assignment. Then I'm much less worried, because I think you have to permit yourself opportunity to stumble every once in a while. We're all trying things out new here. It's okay to make mistakes. It's okay to fumble. It's okay to redo analyses. So I just want to give that out there, is that the quizzes themselves, complete them. That's going to be into your class participation. Okay, so there's the anatomy of a homework assignment, and with regard to, with some asides about the final project. Shall we continue with the concepts and make sure that we have everything covered with regard to categorical data analysis? So I just want to throw out there, if you did miss any of the homework assignments, I know I've said it a couple times, but I know some people are coming later and earlier. For the course, we do permit you to drop the lowest score for your homework assignments. And that's because sometimes you just don't have enough time to finish it. Sometimes you just had a bad week. We've all been there, we've all had that. So if that's the case, then you can just forget about it. It's water under the bridge. I still encourage you to complete the homework assignments. That being said, I'm giving you the spoilers. And the reason I'm emphasizing that proviso, that sort of loophole that we have, I don't want to say it's a loophole, that grading procedure, in terms of dropping the lowest homework assignment, is that we really must have all your homework assignments due by 5 p.m. Eastern Standard Time. That's Boston time, Harvard time. And the reason is because we want to review the previous week's homework, and then we want to move quickly into next week's homework. So after this section, I'm going to post a bunch of R tutorials so you can get a head start on next week's material on analyzing numeric data. And as you can see, the module for next week is already posted. So that's the main point here, is simply we want to move quickly through the course. Okay. So long story short is there isn't really an opportunity to catch up except conceptually. And that's what's really most important to me, is as long as we give you that opportunity to skip a week, as long as you are up to speed with the learning part of it, that's what is most important. Okay. So here we had a mission on the Titanic data. Okay, kind of interesting stuff. I think I could do a poll here if I were really savvy. But how many of you have actually seen the Titanic movie? I have. Good. Good. Okay. So Celine Dion is now stuck in your head, perhaps. Well, I think it's a great film, actually. I rewatched it, and I was actually quite surprised because some of the people in the Titanic who were the wealthiest people. Yes, exactly. Someone had mentioned the lower class passenger. This is Walter, if I may out you, because you're sending it to everyone. There was a lower class passenger who didn't make it out in that one, right? So here we have an example of how class is related to health, or what sociologists would often refer to as your life chances. What are your life chances? Well, in sociology, we kind of think of life chances as a little technical thing. Life chances are your opportunities to flourish, to succeed in life, right? So Jack Dawson, see, I know my Titanic, is, if I'm, spoiler alerts a little bit, sorry, the ship sank. Jack Dawson is in the lower class part of the ship. And he was obviously a talented artist and had a lot to offer the world, but he was born into a, well, he wasn't born, but actually got his tickets and was assigned a lower class position. That being said, he was already part of the lower class. He was an artist. He was kind of a vagrant here. And so while the love story between Kate Winslet, I forget her name, and Jack Dawson or Leonardo DiCaprio is fictional, it does give a good example of how social positioning influences your life chances, whether you're on a ship, whether you are living in life. And this is also an example of, so in that way, it's a study of, a case study of social inequality. In addition, it's a great example of how we can think about history being augmented or supported by statistics. I don't think I could ever read a great historian book of history without the narratives, without the people behind the data. But the data provide us new insights that maybe personal accounts sometimes often don't. So cliometrics is the technical term, referencing some Greek mythology. It's good if you're at Harvard that you can brag to your friends that not only did you learn R programming, but you also learned what cliometrics was. But the point here is that the statistical analysis of history is exceedingly useful. So who survived and who didn't? And I think on this mission, we sort of got an idea of what happened. On Monday, I showed you how using the view function, capital V, lowercase I-E-W, parenthesis, the data set, Titanic, provides you with a sort of a screenshot or sort of a view, an Excel spreadsheet of the variables. And that's what we see here at the top. And let me see if I can mark this. Right, these are the variables here. Sorry, I feel like this is a Khan Academy, a bad Khan Academy. Those are the variables here. But we also know that this is a data frame. And we know this because look at this, there's no variable name here, but there are numbers going from 1 to 6, and it goes all the way down, of course, to 1096, I believe, is our total number of passengers in the data set, but I could be wrong. This is from memory. The point is we know this is a data frame already, even though it looks like we truncated it a bit on the right. We don't have all the variables, 1, 2, 3, 4, 5, 6. Yep, we don't have that. What are we missing now? Survived. We don't even have our survived variable here. Well, that was just a simple yes or no. And I showed you all that last week, basically. But I want to highlight this to you because this is actually very useful for the problem sets and for the homework as well. I'm sorry, for the midterm and for the final. That there's information provided here. A lot of it might be extraneous. A lot of it might be very useful. But already I can tell you when I look at this, I'm looking at what are the variables, and then what kind of way is this presented? Well, I already know this is raw data. In other words, this is like an Excel sheet, because that's what this first indexing row does. When an object is assigned a data frame, is imported as a data frame, all that means a data frame in R speak is simply a spreadsheet where the rows are ordered, but not as a variable, but with just some structured meaning. And what's that meaning? It's how you put the data in to R. So a 1 here doesn't mean anything except it's the first row. This is the second row. This is the third row. The rest of these, you see some example values here. And then the first first row are the variables. Now those variable names could be anything. They could be 25 characters long, so they're truncated. But I just want to give that as an example of what I see. I look at that data, I give it a glimpse, and I think, okay, what kind of questions are going to be asked? Well, the first one it's going to ask you is what kind of variable is class? Well, this is where you go straight to class. And for that, you have to know what I already told you, which requires a little bit of familiarity with R, but maybe some intuition, right? You could sort of see, okay, here are names listed in a roster, right? We've all dealt with this, whether or not we're in elementary school and helping our second grade teacher call roll, although I hope not on the Titanic. Here we see that in what you'll know is that using R, and because we provide only R outputs, you'll know that first row of any kind of subset or raw output from a tabular data frame. I say tabular because it's just like you can write it on a sheet of paper. It's two-dimensional. You have one dimension and you have the second dimension. And the first dimension are the variables, the second dimension are the observations or the rows. So we already know what variable is, we already know where class is because it's listed right here. You can even draw that variable class there. Now we want to know what kind it is. Well, shoot. We can assign numbers to classes, but we know that it isn't. How do we know? Well, part of this is essentially keeping in mind whether or not, looking at the outputs, you know that upper actually doesn't have a numerical value. What's the value of an upper class? Well, economists might tell you, okay, based on Billy Zane's earning potential and all of his works of art, which was part of the Titanic story, he seemed to be worth X amount of money. In fact, that was a subplot point of Titanic was Kate Winslet was stuck between a guy who earned a lot of money or had a lot of money that she was going to marry, Billy Zane here in this case, and then you had Jack Dawson who didn't have anything. Maybe he had earning potential, but he had no 2 nickels to his name. So the point here is the difference between Jack Dawson and Billy Zane in that film, there's no money for them per se, because there are some very wealthy people in the upper class, as well some people who barely made the upper class. An example of someone who barely made the upper class was Kate Winslet's mother. She was saying, well, we don't have any much money, that's why you have to marry this guy you don't love. The point is, there's no numerical assignments to things like social class, especially, and here's the key word for statistics outside of film and this data set, if there are letters, if there are words here. Words are not money, sorry. And I say that to any aspiring poets or musician or or writer, words are just different than money. So to be upper, middle, and lower, it's not a numerical variable. You guys, sorry, I have a little cat here. I'm going to see in your text messages, in your group chat, can someone tell me out of these variables here in this example, I'm going to clear, which one is a numerical? Which one would be correct? If we replace the variable class with a different variable, which one would be correct? Right, we don't see fair. Yep, we do see fair here. Age and fair, exactly. Those are both numeric right here. The rest of them aren't. Why? Because think of what a category is. You survived, you didn't. Think of what a class is. You survived, you didn't. Male or female. What kind of variable is name? Is that categorical? Why might some of you think it is categorical? Why would the name variable be categorical? It's definitely non-numerical. Exactly. I think for broad purposes, we can say it's non-numerical. The main reason we can think of it as roughly categorical, although this is open to debate. I think the more accurate concept is to say name is non-numerical. We can say it's a category, but a kind of a unique kind of category. Assuming that there is only one passenger listed and that these are uniquely identifying the rows, although I'm not sure if that's the case. If there are no duplicates, like duplicate people on the roster, then we can say, well, each is a category of one, right? We have all the, or you could also group name by last name, by family, for instance, or by first name. Names that start with the letter A. I'm not saying you're actually creating a categorical variable there, but the main point is there are many flavors and many ways of expressing both numeric variables as well as non-numeric variables. Some are more ready to be analyzed, such as social class or survival or gender. Some of them are a little bit more difficult, right? So like in this case, name, it's hard for me to say it's a categorical variable. I might call it a string variable. For instance, a string is just simply technological speak for a line of text, for instance. It doesn't necessarily group people. That being said, you can use that information to group people. You know, you can say, okay, let's parse the string. Everything before the comma is the first name. Say, you know, here we have a comma. Everything after the comma is the last name. Okay, here I am bloviating about question 1, but I think it's a good illustration of how to answer questions and how to think about variables in a way that I think will help you for the you know, moving forward, especially for being successful problem solvers here. Now, this is what I typically do. I typically don't like to look at the options here when I answer a multiple choice question. Maybe this might be easy for some of you. You may have already known this, but typically you don't want to be thrown off by the promise of other answers that might seem plausible. What I typically do is I will read the question, especially if it's a multiple choice one with many options. I'll read the question, I'll come up with my own answer without looking at any options, and then I'll see what is the one that might be closest to what I think. The reason I'm saying that is you don't want to be thrown off by red herrings, by false alarms, because often when we write questions, if we write them well, then we, I'm sorry, I'm somehow doing a private message to one of you. I should be messaging to everybody. I want to write the word string to refer to name is string and name is non-numerical. Okay. Now I'm giving a little bit of strategy for answering these multiple choice questions, right? So the first one to do is read the question. Look at the relevant output Find the closest answer. Do not be distracted by similar logically parallel answers. The reason is that sometimes these alternate answers that are incorrect might follow a parallel logic, like they're almost correct, but not exactly. Or they might have two digits switched around if it's a well-written question. And we don't try to be tricky here, but we do try to test whether or not a test, but really want to just make sure that you're following all of the correct steps and all the correct logic. Because there are some more ways to sort of trip up on answering some of these questions than others. That being said, we don't really try to trick you. These are not trick questions here. So how old was Harry Anderson when the Titanic disaster occurred? Well, if you know Harry Anderson as the magician from the old 80s sitcom Night Court, then you might get lost here. But we know that, as I told you from the onset, we're not referring to some B-list celebrity, although I do like his magic. We're actually referring to, again, the output in question. So we look at kind of Mr. Harry Anderson. We can see that, and there we go. We can go straight to age. We're just looking at the outputs. Right, so here we have another age, 29, 26, and 25. Right, it might be a little confusing because see here we have fair, that's 26, so that can be kind of similar. If you misread what the column is, then you might answer with 26. So that's a good example of why you don't want to be moving too quickly, and why it's sometimes worthwhile to invest in understanding what this is, but not too much time because there could be a lot of extraneous information. I'm not sure why 25 was thrown in there, except it looks a lot like 26, right? It might be a little disconcerting to see a bunch of 20s here and then a 48, but that's okay. Okay, let's scroll down if I can. Come on, whoops. True or false, no children under the age of 5 died on the Titanic. Oh, sorry. 3, did Helen Lorraine Allison survive the sinking of the Titanic? Well, here you don't see the output, I'm sorry. Well, here you go to the name here. So one thing you have to notice here, and actually even made a mistake here. Everything before the comma is the first name, and we know this because of the titles here. Everything after is the last name. So that's a little bit of a detail that you might want to understand. I agree. Someone else had said, write them out separately as problems get harder, like a spreadsheet. I totally agree. Scratch paper is great, especially if you're doing even some of the arithmetic. I often define my problems, define the elements of those issues, especially if you're going to answer some questions that require you to have 3 or 4 different concepts and that you're going to have to rearrange in an equation. But that's later, but I totally agree. So did Helen Lorraine Anderson survive the sinking of the Titanic? This requires you to look at this S column here that I guess just because of I downloaded this as a PDF, we lost that. But we can just see that there'll be a yes or no there, and that's easily answerable. She did not. So there would be a no survival, I believe, for survive there. So that also requires you to understand what yes and no means in the context. True or false, no children under the age of 5 died in the Titanic. Well, here, this is where I'm going right now. I'm looking at the 1 and the 2, and then I want to see if those 2 kids survived. Now, of course, this doesn't have all of the data in the Titanic. So if there are children that we observe to have died from this subset of 6, then we can reject the statement that no children under the age of 5 died under the Titanic. In other words, children did die on the Titanic. So this requires you to deal with double negatives, true and false. Sometimes it's easier to reword the phrase, right? No children under the age of 5 died under the Titanic. The main question we want to know is, did children die under the age of the Titanic? Yes or no? Well, yes, they did. Okay, so did no children die? Yes or no? Well, it's the opposite of children dying. So no children died. So that's a false statement. So that's a little bit more about language. But of course, this is where statistics is really a lot about language and interpretation and about really understanding those details. This is actually some of the hardest parts with stats. I don't think it has to do with programming. I think it has to do with critical thinking. I think everyone else would agree too. I know we have 10 minutes left, but I might skip some parts, but I hope this was useful. And I think this has taken a little bit longer because I gave you a bird's eye view. But I think I'm going to try to get to about 10 after here. So about till 9:40, 9:10. Just because I don't want to rush, but I think it's also important to review these issues. So here we have a new bit of outputs, right? We have survival and we have social class. And then we have something called total here. If you recall from the data analysis and from the modules, total here is not part of the class variable. It is simply adding up all of these numbers that comprise lower, middle, and upper. In other words, it's the total number of people who did not survive, the total number of people who did survive, and then see if I can highlight. I think I have it. Yeah, the total number of people who did survive. See, I can make that a little better. And then the total number of passengers. So I was off by 4. We have 1,045 passengers. Okay, and we also have the totals, by the way, for each social class. And that's what happens when you do a two-way tabulation. Well, I'm not going to go to syntax here, but if you talk about what margins are in the R console, margins give us these totals, whether they're by row or by column. Okay, so now we have based on the information from table 1. Well, there's no name to this table, but keep in mind we're typically referring to the last table that we provided for you. You might want to think, oh, this is the first table. Well, it's not a table, it's a spreadsheet, first of all. And second of all, remember that logic that I gave you before, which is we're now going to ask you questions about the last bit of output that we gave you. And also you might want to think of what a table is. A table is typically aggregated or analyzed data. In this case, these are the counts of 2 categorical variables. It is not the raw output here. Let's just confirm that. Yeah. Right here we have the first level rows of the data set. So that's not a table. The table is often aggregated data. Okay, so question 5, based on the information from table 1, how many passengers survived the Titanic disaster? Well, remember survived, I said that we have a total here. There's the number. So notice I didn't even look at the options here. 477, okay. I did not waste any time looking at these other options. You can do that, but you're going to perseverate. Okay, move on. How many passengers survived the Titanic and were members of the upper class? Ooh, this is an interesting question. It's about the joint probability of 2 categorical variables, which is of course what the table represents, but also their joint distribution. So if you have someone who survived the Titanic and were members of the upper class. Now this might help you, especially if you feel like you're struggling at this point, this might help you to parse this question into 2 bits of information. You want to know how many who survived the Titanic and were members of the upper class. Well, you look here, how many survived the Titanic? Okay, you go to the yes column, and then were members of the upper class. Then you can just draw a line and you can be, okay, upper class. Oh, well, there it is. Bullseye, 181. This is the intersection, the joint probability of belonging to both the upper class and the survival group. 181 out of 1,045 passengers. And there you go. And here I'm going to skip all of these red herrings. Look at that, how that streamlines the answering of the homework. Question 7, how many passengers did not survive the Titanic and were members of the lower class? Same thing, same logic. I'm not going to address that. So this is a different way of asking the same question with a little bit of with a negative there. You know, you can say what doesn't do something, what does do something. Overall, what percentage of passengers survived the Titanic disaster? Okay, well, this is a little tricky, but requires you to simply take the number of passengers who survived and the total number. So if you think of the Titanic disaster, that's everyone, and that's the passengers who survived. So where we do that? Well, we look at the passengers who survived right here, and we're going to take that and divide it by the total number. We're just making a fraction, right? We want to know the proportion of those who died, who survived. So this would be 476 divided by 10 equals fraction, percent, whatever, survived. Well, what's the logic here? You want those who did something over everyone. That's all it is, right? So sometimes we'll ask you to do those kinds of questions. Again, that's basic arithmetic, but this require you to understand, notice I started the question, dissecting what are the meanings of the rows, the columns here, whether or not total is part of this variable name, because this is a categorical variable, whether or not total is a meaningful word. And of course, we see that that is not the case here. Okay, so let's continue. I'll try to do a little spotlight here just so it's a little bit easier to see. Yeah, and that's worth a little bit more, and we round that to 2 decimal places. We won't be any trickier than perhaps a few full integers of a decimal place off, sorry, full integers of a percentage off. So if you find out that you've come up with 42.38, we're not going to give you an answer that has 42.36. Which is, we're not, statistics, as you'll come to learn about it, is not about precision. We don't care how many digits you memorize to pi. We just want to know that it's around 1.14, 3.14. See, I don't even know. Pi Day, March 14th, 3.14. That's a, you know, that could work in most cases. That being said, precision is often important in engineering and those kinds of applications. But there's a certain point when we're talking about inference, we know that what we derive from a sample, from a limited sample, isn't going to be truth, but it's going to be an approximation of truth. So we're really more interested in how close, what's our general bullseye, because our estimate is always going to be inferred with a confidence interval, and that's later. Right now, we're just talking about understanding what categorical variables are and interpreting those. What are the variables in the data set? This is the very first question. Yes, I know. Someone had mentioned they are super strict in some classes for numerical analysis. It's a big debate. I think it causes more problems than not, especially on the grading end. In fact, when we had open-ended answers, what you can find, and this is the problem, is that you can find that students know the concepts, but they might have rounded, done what we call mid-rounding. If you have like 3 or 4, let's say you have 3 numbers and you're going to add those up, and you round 1 to 2 decimal places, 1 to 6 decimal places, or 1 to the default, which is an R, it's to 16 decimal places. Well, look at that. Even R, the highly touted stats program, is rounding. It even commits the same sin that the rest of us do. So there are so many questions with rounding that you can come up with a problem that, because of propagation of error, you round one number and then do the rest of the beautiful equation, that you might come up with a number that's quite off, that we don't anticipate. Instead, we provide you with multiple choice answers, because I think that's a clearer way of emphasizing, communicating, and also preventing punishment of clear thinking with some discrepancies in rounding. So that being said, I could talk about rounding. It's an interesting topic, but yeah, precision is overrated, because any kind of estimate that you have, say in later weeks, say you do a poll of 2,000 Americans about presidential approval, look at any polling report, you will not see that percentage more past 1 or 2 decimal places. It just doesn't make sense. Anyway, we can talk about precision later, but especially with inferential statistics, when you poll 2,000 people and you want to infer to all Americans, it doesn't help anybody. That being said, I know some of your output stretches your answer to 16 decimal places. Don't worry about that. Okay. So approximately how many people were in the lower class of the Titanic? Well, this is probably where it behooves me to look at some of these answers. by bringing up the homework. But I'll do it. Fair enough. If you can bear with me. But again, this is really just interpreting the output that we had earlier. This isn't going to be quite different. But I think it's helpful to review that output. Any questions as I transition? So maybe I'll be 15 minutes after. I know it might seem a little rambling, but I think it's useful that we're comprehensive, so that way each week you can wrap it up. Okay, thank you guys. Thanks for the kind words. Is there anything that you find particularly useful? I'm not going to take victory laps about what is useful. I'd like to know how or why. This is the follow-up question to any kind of analysis. Is there anything you'd like to hear more of? Good. Yeah, that's I think something that we heard in previous sessions. We do listen to you guys. Okay, so here we are. Looks like I'm dealing with the homework assignment from before. Let's look at our packages. Remember I told you we can install packages and we can install them doing drop-down menus, but let's just take a look here. Oh, I have it installed, so I did do the install packages function. I'm not going to go down the rabbit hole of coding. I did this because I can see it here, but now I need to program it, so I'm just going to click it. And look, we downloaded it and we got it going. The other way to do this, of course, is to also highlight that. But I want us to get into the homework assignment. So here we are going from 10 and beyond. I'm just going to run all the scripts. So I'm not going to run everything, but this is what you should do. Once you download everything and you run it, you'll see the god-awful decimal places too. I think that's 6. That's just the outputs. But I believe it's cut. R stops at 16 significant digits. Okay, so let's scroll up. This is how I would answer this question if I were doing the homework. I ran the scripts, and then you go here. Well, what are the names in the variable data set? Oh, okay, just cut and paste. Easy. Okay, well, this is not even thinking. This is just sort of spitting back what's going on here. Boom. Okay, you have to select all that apply. Are passengers in there? Well, that's tricky, isn't it? Is passengers part of the data set? And this is why I like the question, I think why we kept it in. No. And if you got this wrong, I'll tell you why. Because it's quite tricky here. Let's take a look at the Titanic data set. Keep in mind, remember I told you this column right here means nothing. It's not a variable. It is just an index internally within R that tells us it's a data frame. It tells us the number of observations. Doesn't tell us whether these are passengers. These could be Martians here. Let's say we had a Martian spaceship that we called the Titanic, and they decided to replicate everything. They were really big on cosplay. Oh, I'm sorry. I'm not even showing my RStudio output. That is not good. I apologize. You're absolutely supposed to see my RStudio. My bad. I hope you guys weren't too lost. Okay. I wanted to show to you that basically what I did is I highlighted, I'm just going to do a little bit of repetition here. I highlighted this right here. I did not do anything to this because I had already the packages installed. And I knew that because I clicked on packages and I had it installed. Let me deselect here. I just detached or uninstalled those packages. But what I did is I showed you how you can install the package either through the command line. Sorry, you can invoke the libraries here, and you'll see these highlight right here. And because I've already used R and I installed packages last time, I don't have to deal with it anymore. Now I'm going to tell you how to deal with the problem set code. You just highlight all the code here, and you can highlight everything else, but let's just stop at question number, where the heck is it? 14. Okay, we're going to be we're busy, you know, we have other things to deal with. We're going to just go through 10 and beyond, and we're going to run that. And you're going to see in the lower right-hand corner, let me move this so we can see everything. You should be able to see the full screen. Can you see my output now? Can you see a console in the bottom? Yes, thank you guys. And you see the plots in the lower right-hand corner, and you see the script here. Let's go back to the code. remember I told you green text is commented out. I certainly spend my fair share of time talking about that code, so I'm going to just do a quick save. Ugh, it doesn't know where my file is. That's okay. I changed the location of what I did because I finished the section. It doesn't matter. What I want to point you toward is when you do answer the questions, you're going to look here and look at where the question is. You're going to look at the commands that are run, and you're going to look at the output here. And what I want to show you is that here we list for you, we're basically giving you the answers, kind of, right here, and showing you how to do it within R. So most of your answers, and I'm going to do a new share. Or actually, if I can, I'm going to share the whole desktop, okay? So let's do this again. I'm going to do a share screen. I'll share my desktop. There you go. You should be able to see everything now. Okay, good. All right, so you can see everything. You can see the time, sorry. And what I want to emphasize here is here we have the homework assignment itself. Here we have still a title thing. And then here we have the R outputs. And this is where you're going to work interactively with the homework assignments. The point is you're going to find your answers to the homework assignment in two places after you run the code. If I can annotate, I'm going to do the spotlight here. You're going to find your answers here in the plot function, because these are all the plots that we created. You're going to find it here in the console in the output that is black. So if we go to our problem set, question 10, which are the variables in the data set? Select all that apply. Now here we are being strict. If you don't answer, if you don't select all of these, then you will be demarcated. Look at what is not highlighted, passengers. I emphasize this because if you recall in the first part of the problem set, I talked about, there's a method to my madness. The reason I was talking about the variable names in the output is that the data frame in R has that first column here, but there's no label. That's because that's not a variable. That's just an indicator within R that tells your computer, this is what I want to call the first row, this is what I want to call the second row. It's almost like pretend play. If you have any young children or niece and nephew, and they'll say, okay, let's have tea, and you are the tea master, and then you are going to pour the sugar. Sort of it's an assignment that goes on. It's somewhat arbitrary. Someone has a message. I think if we're doing full screen, everyone will see that though. It's an index value. I don't like to use the word value though, and I'm being persnickety here because words are important when we talk about stats. It isn't just about the numbers, it's about the language we use to describe that. Because this has no numerical value. This is not a numerical variable, although you might be able to create one, right? You can just create an index that has a numerical value, although it doesn't really make much sense to me. I'm not sure why the 22nd passenger would be more than the other. What you could do is maybe you could rank by fare, and that's a numerical value. And as you'll see, ranking variables are numeric. That's what you learn in this week as well. The main point is within R and with data sets or data frames, the index here doesn't mean anything, and it's not a variable. So you might want to, a reasonable person might think, oh, this is a passengers variable. Nope, this tells you nothing. Even though the rows are passengers, even though this identifies what order in the data set you are, okay, I want to look at passenger number 127. That really means nothing. It just means how you how you put in the data. So that's something important there. Yeah, I would say, I would actually call that an indicator variable. Indicator. It's good for merging or melting data frames. Just to give you that kind of answer. Because let's say you want to pull people on the same data frame who are ordered in the same way, and that means something. You might be able to put them together, append them, or merge them or melt them in a way that you might, say, zip up a jacket. It's a way of data management, but that's beyond the course. Okay, among those who are male, what proportion of men survived the Titanic approximately? Well, if you're freaking out, as the best of us are inclined to do, well, here we are. Well, look, there are a lot more numbers. What I thought Nate was talking about precision, right? And I would never otherwise use myself in the third person, by the way, but I was just making a little bit of a joke here. The point here is that output that I'm highlighting right there is all the information that you need. It's all the stats that's fit to print. So what proportion of men survive the Titanic approximately? Well, when we're talking about proportions, keep in mind, we're always talking about something that's bound between 0 and 1. So even though there's a bunch of gobbledygook here, we know that what we did here is we split the sample into 2 groups, male and female, and then we saw the proportion of survival for each one. How do we know we split the sample into 2 groups? Each column adds up to 1. You can't get bigger than 1 when you have a proportion. So, and that's where we come up with 21%. We just looked at that number here. What proportion of those who survived are male? So that's how we figure that out. Among those in the lower class, what proportion survived the Titanic approximately? That's this same question, only has to do with this lower class stuff. Are social classes in surviving the Titanic related to one another? Well, that's a good question. What do you think? Well, the numbers seem to be the case, because look at survival. If you look at the proportion survived in lower, it's 26. Middle, it's 44. Upper, 63. Someone is asking a problem setting about unique identifier. Yeah, I agree. We can say unique identifier, but I don't want to always say that, because this indicator right here, if we talk about it, someone had asked, well, can we call this a unique identifier? Yeah, only if they're unique. It's really more just, I would call it an index for the rows, because let's say we have multiple reports of people. You know, there are always data entry errors, especially the farther back in history you go. They may not be unique. Also, let's say our names, you know, maybe the name roster got washed out, and we only have family names. Well, then we don't really have unique identifiers, because you only know what family you came from. So that's just a different way of thinking about things. Yeah, so those of you asking about some of the tally function stuff, here's the issue with some of the stats in installation. There are many sources of these kinds of errors. I would say try rerunning the install. If I could put my 2 cents in, I would say, and it's worked for me, try rerunning this. Just run it a couple times. I'm not going to restart it, but try it a couple times, because I've seen that occur when I troubleshooted with individuals. And you also want to make sure that you use the drop-down menu right here, File, Open File, and then you're going to open the Titanic data set, and it should look like this. Make sure you do both of those. Otherwise, you're going to run into some errors. So, but technically, if you're online, you highlight both of these and you run both of these, and then you do File, Open. You should be able to have it, as long as you're seeing what I have right now. Okay, let's move quickly to the rest of this. Okay, so our social classes surviving the Titanic related to each other. Seems like it's the case here. So if we go back to our Titanic example, I'll end up in about 3 minutes. If we look at who survived Titanic, it looks like it's the case. So Kate Winslet apparently only had a 63% chance of survival, 64. Jack Dawson still had a reasonable chance of survival, 26%. As Kate Winslet said in a recent interview, well, she sort of thought that that door at the end of the movie probably fit both of them. That's probably the case. That being said, it didn't. But the point I want to make here, broadly speaking, is statistics is not destiny. There are always exceptions to the rule, and those exceptions actually help to establish the rule. So you're not doomed by statistics, in fact, even if it's history. And I want to show some more plots if we can show you. I'll just show you, I think we did some bar graph of survival. I think this is the one right here that I want to show. Yeah, okay, well there's a bar chart. We can also do some mosaic plots. I know there's some debate about that. But what I want to show you is if you look at, I like this one a little bit better. If you look at social class and you look at survival, you'll see that most people who died were in the lower class. That's the largest group in the full group of passengers. But you also see that class seems to be graded, right? It seems to have sort of a trend there. And I emphasize this because sometimes if you compare say a mosaic plot or some other kind of visualization, such as this bar chart that I have here, if I can go back to that, sorry, you can see, yeah, it looks like, well, that's not as clear. I like the mosaic plot here. You can see that in the mosaic plot, just in 3 sentences, the x-axis shows the distribution of class, so that the length of each side of the box is proportional to its prevalence in the sample, and the y-axis shows the overall prevalence in the sample. So you'll see overall, among those in the upper class, sorry, not in the full sample. The x-axis shows the prevalence in the full sample, the distribution, and then the y-axis shows the contingent distribution based on the social class you've been assigned. And this is why it's useful if we want to think about survival as the outcome. That's why we put it here on the y-axis. We can see that survival is clearly related to social class. And I feel like that's a lot easier than these very precise numbers, right? So to go back to your question about precision, well, it's good to be precise, but I don't know if you want to show that people died and it's related to class. Class matters? Yeah, it does. So I hope this helps. Just to recap, I know we went over. I took you through the anatomy. I'll stop the share so you can see me. I took you through the anatomy of a homework assignment, and it's going to be similar going on out. I addressed some of your questions regarding the final project and how those relate to some of the code that we might learn, as well as essentially how to think in this sort of preliminary part of the semester, how to think about the final project. Then I took you through the multiple choice questions and how I tackle multiple choice questions, especially when there are several numeric answers, right? I look at the outputs. I look at I try to come up with my best answer. And between those two, between coming up with my best answer and looking up at the output, I will use scratch paper and I'll write down everything I know if that's relevant. And then I talked about how on the second half of the assignments, how you're going to see familiarity from here on out. You're going to see, and I emphasize this, you're going to see a data set, you're going to see scripts, you're going to see both of those together, and you're going to see relatively common flow going on where you can run all the code, but it's still up to you to interpret it. And sometimes it's a little janky, it's a little messy, right? All those decimal places, and we're asking you for an approximation of that. Well, guess what? That's the life of statistics. We are much more than anything, and as much as AI will take over so many fields of industry, it still helps to have good, solid human judgments to interpret this. Much as you still need people to interpret, what is the meaning of a work of art? I sometimes think statistics is an art of a sort, in the sense that it requires judgments about, well, what's the best way, the most aesthetically pleasing way to present the data that it gives the intended impact that you want, while still being concise and honest. I think I went on a little bit of a tangent there, but I just want to go back to what I did in the second part, which was emphasize the role of the code and the analyses, and walk you through interpreting and answering those questions using primarily the output in the console, which is the lower left-hand corner, but also at times looking at the figures that we create and that we provide you in the homework assignment, because that permits you to see trends that don't exist, or that aren't really, trends that you may not see in the actual outputs. And going forward, I hope you have an easier idea of what to expect. We're not going to change anything going forward. We're not going to provide trick problems, but you are going to see some similar types of questions in the midterm and in the final exam. That is to say, you're going to see instances where you're going to have outputs, you're going to have to provide an answer, you're going to have to interpret it. For the data analysis part, you're going to have the final project, and that will require you to, take on either a data set that we have, a new data set, and codes that we provide, or new codes that you really want to go soar with to provide your own kind of interpretation or your own novel analysis. So, and we can talk about this later on, but I think that's it. Are there any other questions as we end? Now at a little bit over an hour and a half into this. Yes. Okay. Thank you. So Monday's session is going to be about numerical data analysis. So the way I'm sort of doing one and the other is essentially Monday is going to be a little more stats heavy, although I'm trying to use as much on the R tutorials to try to offload that because a lot of it's technical. That being said, I'm going to emphasize more on the data analysis on Monday, and unless you have further questions. And then Thursdays is going to be our recap of what is it you just submitted, so you can sort of close that off and then move on. That being said, you're going to revisit a lot of this material later on. So someone is asking about whether or not we need to submit a topic proposal. No, not at all. That being said, I strongly exhort you to meet with your TA, your assigned TA, for the final project. And I say assigned TA because we've divvied up the who's in charge for grading your final project. So while I can give you plenty of advice, I may have a nice, collegial academic disagreement with my colleagues, and that may have an effect on your grade. Just for emphasis, I want to clarify that point. Aside from that, grading of your homework assignments and sort of assessing student progress, that's better, best. I would just say, put it this way: grades, talk to your TA. Concepts and other things, in general, all of us on the teaching staff are here for you at any time. So feel free to reach out to me. And I think, so in other words, there's no interim thing. That being said, I think some of my best students, and the students I still remember even a year afterwards, are the ones who reached out to me, because, every sort of research project has its own little quirks. But what I want you to know is that this education is for you. Make it useful for you. Be self-interested, right? If you have a dissertation idea and you want to know a data set, focus on that. If you are a computer programmer and you want to, say, learn R integrated with some other workflow using Python or something, or some new library that's beyond the scope of the class, we can talk about that. But you can do that too. If you want something that maybe is what you feel like you're done with this class, you're too busy, you can use the data sets in the class, or even some built-in data sets, and I'll show you those. But just make sure you are not replicating or regurgitating what is said before, but that you're giving your own spin on it. So make it useful for you. It's your education, you own it. Thank you very much, guys, and I'll see you Monday. Tomorrow, I'm gonna give you a bunch of videos on numerical data analysis using R. And my bit of advice, if you're bored, because it's like 20 minutes, because everything lasts longer than I expect it to, watch it at double speed, okay? And all the recorded sections are available online. There are some questions on the discussion board. I tried to rectify this to the best of my ability. Go to the discussion board. I'll even send out a notice because I don't want that to be any point of confusion. I did have one YouTube video that it was locked. Other students have said that the YouTube videos are blurry. Don't watch them on your iPhone if they're too blurry. Watch them full screen, and don't watch the embedded video. I know it's a little hard to see some of the scripts, but this is the best we can do. And make sure you watch it on high definition, because if you watch it, I watched it on full screen high definition. And if you're familiar with the homework assignment, you shouldn't encounter any difficulty. Okay, thank you very much. But that being said, if you still have problems, let me know, because last year I used YouTube and we had no issues. So it might be YouTube's fault. Okay, thank you guys. And always, as always, I haven't held office hours, but please, any questions, final project, other things, there's my email. I also am accessible on WhatsApp or on my cell. If you're going to leave a message on my cell, please leave a voicemail so I know that it's a student from the class and not spam. Please, we're here for you. And if students are really not responding, I might even do office hours, but we'll see. Virtual office hours. Okay, thank you very much, everyone. Take care. And if you don't have R installed, tell me. All right, have a good night.